Hello, everyone. In this video, we will look at class design guidelines. You have learned how to design classes from the preceding example and from many other examples in the previous chapters. This section summarizes some of the guidelines. First, cohesion. A class should describe a single entity, and all the classes operations should logically fit together to support a coherent purpose. You can use a class for students, for example, but you should not combine students and staff in the same class because students and staff are different entities. In the Java API, we have the classes string, string buffer, string builder. They all deal with string, but they have different responsibilities. String class deals with immutable strings. String builder class is for creating mutable strings. And the string buffer class is similar to string builder, except that string buffer contains synchronized method for updating strings. Consistency. Follow standard Java programming style and naming conventions. Choose informative names for classes, data fields, and methods. A popular style is to place the data declaration before the constructor and place constructors before the methods. Encapsulation. A class should use the private modifier to hide its data from direct access by the clients. This makes the class easy to maintain. Provide a getter method only if you want the data field to be readable, and provide a set method only if you want the data field to be updatable. For example, the rational class in the preceding section provides a getter method for numerator and denominator, but no set method because a rational object is immutable. Clarity. Cohesion, consistency, and encapsulation are good guidelines for achieving design clarity. In addition, a class should have a clear contract that is easy to explain and easy to understand. Completeness. Classes are designed for use by many different customers. In order to be useful in a wide range of applications, a class should provide a variety of ways for customization through properties and methods. For example, the string class contains more than 40 methods that are useful for a variety of applications. Instance versus static. A variable or method that is dependent on a specific instance of the class must be an instance variable or method. A variable that is shared by all the instances of a class should be declared static. For example, the number of objects in the so-called class in live example 9.8 is shared by all the objects of the so-called class. So this is number of objects, and that is declared static. Now let's look at this is a bad design. Here is, you have this constructor, and now you're going to pass something through the constructor and to initialize a static data field. That is wrong. Because all things in the constructor should deal with a single object and for that object's properties. For the static feature, you should initialize it outside the constructor. You can provide a method and you can call it, and from that method, from the class name that method to initialize it. Inheritance versus aggregation. The difference between inheritance and aggregation is that the difference between the is a and has a relationship. For example, an apple is a fruit. Thus, you would use inheritance to model the relationship between the classes apple and fruit. A person has a name, thus you would use aggregation to model the relationship between the name and person. Interfaces versus abstract classes. Both interfaces and abstract classes can be used to specify common behavior for objects. How do you decide whether to use an interface or a class? In general, a strong is-a relationship that clearly describes the parent-child relationship should be modeled using classes. For example, this here, orange is a fruit, so their relationship should be modeled using class inheritance. A weak is-a relationship, also known as an is-kind of relationship, indicates that an object possesses a certain property. So for example, strings are comparable, integers are comparable, dates are comparable, so we define the comparable interface for this purpose. That is all for the summary of the class design guidelines. These are the sound recommendations and for help you design and good classes. Thank you all for watching. See you on the next video.